Yes, good morning, everybody. And here is the course on microcontroller programming. And let's see what we have learned in the previous class. So, there we have seen what is a computer basically. So, there we have seen that it is a digital machine which accepts data from input devices and performs certain operations on the data as per the instructions we have given and produces a result. Okay, and the result is given to your output devices, right? So this is what a computer means. And next we have seen what is a microprocessor. So microprocessor is an IC, or integrated circuit which contains in the same IC the following circuits: ALU, control unit, and register array, all on a single IC. Then it is called as microprocessor. So if all of these are present on different ICs or different circuits, then it is called simply CPU or central processing unit. If all of these are present on a single IC, then it is called microprocessor. Then we have seen one more thing, that is what is microcontroller. Is an IC which contains not only the microprocessor on it, but also it contains memory, IO ports, and other circuits. Right. So, what is the purpose of microcontroller? You know what is the purpose of microprocessor or a processor? The microprocessor or a processor is used inside your computer to perform a number of tasks simultaneously. But what is the purpose of microcontroller? So microcontroller is used in applications or in appliances like your washing machine, refrigerator, AC, etc. Okay, to perform only a specific task. Specific task. That means, say for example, controlling the devices. So based on certain conditions, it will control the device. For example, if you are using a microcontroller inside your AC to sense the temperature and maintain the temperature of a room. So, maintaining temperature of a room is specific task for your AC present at your home. So, maintaining the temperature in your room means first it has to sense the room temperature. If it increases, it has to provide more cooling. If it decreases, it has to provide less cooling. Right. So the controller is the one application. By using with the help of sensors, it will sense your room temperature, and if it is more, it will control the device called the cooler, which increases the cooling effect. And if the temperature is less, it controls the cooling device so that it provides less cooling, so that overall the room temperature is maintained at a given temperature. And for this, microcontrollers are used everywhere in almost all appliances that we are seeing and using every day. And a lot of so there exists a number of varieties of microcontrollers. So the number of varieties of microcontroller ICs. Okay, for example, we have 8051 AVR and PIC microcontroller and ARM microcontroller. So these are all the varieties of microcontrollers that will be used in various appliances. And since we are the new to the microcontroller subject, so first we're going to start with 8051. Later in some advanced courses you may be studying the other controllers, about the other controllers. So what we are going to learn in this. So here we start with Intel 8051 microcontroller IC, and we'll see the features. What are its special? What is special thing about your 8051 microcontroller? And we'll draw the functional block diagram. Functional block diagram means 8051 is an IC. That means it has some circuits inside it. So instead of going through in detail about the circuits, we'll divide the circuit into a different number of blocks, important blocks, and we'll see what is that functional block diagram, and we'll describe the function of each of those blocks in this lecture. So first we'll go with features of Intel 8051 microcontroller. Features of Intel 8051 microcontroller. So we have seen what is how a microcontroller actually looks like. How a microcontroller actually looks like. We have shown here in the slide. So this is an IC, simple IC. Simple IC here we can see. And now we are studying what is there inside it. Okay. And why we are studying all this? To make use of this microcontroller to control or to perform a specific task. And here you can see that the Intel 8051 is an 8-bit microcontroller. So it is called, the controllers will be of different bits. Some controllers will be 8 bit, some will be 16 bit, some other will be 32, and some other will be 64 bit. So what is this mean by 8-bit microcontroller? Means it can process the data in group of 8 bits. That means whatever the data that you want to give it as input for your controller, it will divide the entire data into group of 8 bits, and it will process the 8 bits of data at a time at a particular instant. And after processing that 8-bit data, it will take next 8 bits of data and it will process and go so on. Okay, so that is why it is called 8-bit microcontroller. And who is actually designed this microcontroller? Means Intel. You know, the famous chip designing company Intel. The Intel has designed this 8051 first in the year of 1981. Okay, and one more feature is that it's a 40 pin IC. You can see that here in the previous slide I have shown the IC. It has 40 pins. What is the purpose of these pins? These pins are actually connect the circuit inside to any other circuits that are present outside this IC. Okay, that means these pins you can see here on this side you have 20 pins, on the other side you have 20 more pins. Total it's a 40 pin IC, and it works on 5-volt DC power supply. And you seen that this is a digital 8051 microcontroller is a digital IC. Digital IC means um, it is made up of some digital logic gates. Okay, digital logic gates, and it is a sequential circuit. Sequential circuit means it requires a clock for its operation. So here also 8051 operates on 12 megahertz clock. So 12 megahertz is the frequency of the clock required for operation of your 8051. In the same way, we said that the controller has RAM and ROM on the same IC itself. So how much RAM is there for your 8051? Means 128 bytes of RAM is there on the 8051 IC itself, on the same IC or on the same chip. So that is why this 128 bytes of RAM is called as on-chip data memory. On-chip data memory. On-chip means it is present on the same IC, and it is called as data memory because the RAM is used to store the data. RAM is used to store the data. So that is why this 128 bytes of RAM is called as on-chip data memory. Similarly, it also has a certain amount of ROM, the read-only memory. So it has 4 kilobytes of read-only memory. So this 4 kilobytes of read-only memory, we can call it as on-chip program memory. On-chip because it is on the same, it is in the same IC of 8051. So that is why it is called on-chip. Chip means here IC. So on-chip, and it is called program memory because in the read-only memory we actually store instructions, and a sequence of instructions or group of instructions is called program. So that is why this 4 kilobytes of ROM 8051 is called as on-chip program memory, right? And also it has 32 IO lines. 32 IO lines means 32 input and output lines. So ఎందుకు input and output lines? For example, you want to give input for your controller, there must be some connection. Okay, to the circuit that is present inside your IC. Okay, and that connection we are calling it as input output lines. So that type of IO lines are input output lines are or input output pins are there for your 8051, which are 32 in number. Okay, 32 in number, and these 32 IO lines are categorized or grouped into 4 ports. Okay, 4 ports means each port will contain 8 of these IO lines. ఒక్కో దానిలో 8 IO lines ఉంటాయి. టోటల్గా we have 4 ports. Total we have 32 input output lines. And the ports into which these 32 IO lines are organized, they are named as P0, P1, P2, P3. That means port 0, port 1, port 2, port 3. The names of the 4 ports into which these 32 IO lines are organized. And also it has some, we already said that controller not only has it has processor, it has ROM, also it has some other control circuits. And what are the other control circuits it has means here this 8051 has two 16-bit timers and counters. So it has the extra circuitry which is called as timers or counters, and they are of 16-bit size. 16-bit size means they will accommodate 16 bits. So such timers and counters are there. For your 8051, which are of 16-bit, which are 2 in number. And similarly, it has the extra circuitry called as interrupt on the same IC. See, all of these are present on the 8051 IC itself. So that is why this is the advantage of the microcontroller compared to your microprocessor. So it has 5 interrupts on the same IC, and it has a total of 111 instructions. See, 111 instructions, and these are not present on the IC. Okay, but these many instructions are the one we can give to your 8051. So these many instructions are understood by 8051 microcontroller. So why we are giving all these instructions? For example, we can give an instruction to add the two numbers. We can give an instruction to perform logical AND between the two numbers, and operation between the two numbers. A similar way, for example, if you want to perform a task, for example, if the room is dark, then switch on the light. So this is the task given. You can give to your 8051. So this is the task, okay, and this task can be achieved by writing number of some related instructions. ఒక 10 ఒక some number of instructions రాసినప్పుడు then we can achieve this task. And if you give all those instructions to your controller, the controller 8051 controller will execute all of this, and it will sense whether room is dark or not, and depending on that it will either switch on or off the light. Okay, so this is how we'll make use of the 111 instructions that are available with your 8051 are understood by your 8051 to write the programs. Next, so these are the features that 8051 microcontroller has. Features means what is available with your 8051, and by seeing this what is available with, you can make use of all this. That means you can use 128 bytes of RAM, you can use 4 kilobytes of ROM, okay, and also you can use 32 IO lines, and you can use 5 interrupts, and you can use these 111 instructions and two 16-bit timers to achieve the task that you want to uh, get it done by your 8051 microcontroller. Right, so next we'll go with the functional block diagram of 8051. Functional block diagram of 8051. See what we have shown in IC. We have shown the IC here. We have shown an IC here, right? And what is there inside the IC is a circuits. Okay, lot of circuits. You have seen maybe uh, some memory circuits, some AND gate circuits, some flip flaps, etc., etc., in your digital electronic circuits. Okay, and by combining all those basic circuits, we build a very big circuit for 8051, and that is placed inside your what is called this chip. Okay, and to connect with the various points of the circuit, we are available with the pins. These are called pins, the white LEDs, the white metal pins. We are seeing that these are called IC pins. And now what we are seeing is that we are not going with the in detail circuit, but divided that total circuit that is present in your 8051 into certain important functional blocks. And what are the important functional blocks here you can see, and how they are connected. How they are connected by using a connecting wires inside, or by using connecting wires inside your IC, that is shown as a functional block diagram. And just go through the functional block diagram to see what is present. And what we said, the microcontroller has first the CPU on it. So this entire thing is present on the 8051 IC itself. And what is the important thing? That is CPU. So CPU is the one functional block and the very important functional block, right? And apart from CPU, what we said in the definition of microcontroller, it also contains certain amount of memory. Okay, so here we have shown the memory on chip ROM for code. Code means here it is instructions or program. Okay, so on chip ROM for code is there, and also on chip RAM is there. And apart from this, we say that the CPU is a sequential circuit, so it requires a clock circuit. So that clock is generated, the clock generation circuit that is called as oscillator is also shown here, for which you have to connect the crystal oscillator externally. Okay, so this crystal oscillator is not present, it should be connected externally. And next you can see that there are certain IO ports. What we said that there are four IO ports, P1, P2, P3, P4, or you can call it as P0, P1, P2, P3. And also you have certain serial ports, and also you have a special circuitry called timers or counters. So there are two timers. The timers are named as timer 0 and timer 1. And you have one more special circuitry that is there, that is called as interrupt control. So just look at what are the various functional block diagrams in this, and we'll discuss in detail about what each functional block will do while your 8051 executes instructions, or 8051 executes, now that performs the operations as required by your instructions, right? So next we'll see the description of your functional block. The first main functional important functional block is your central processing unit. Okay, the microcontroller has the main functional block and the CPU, which forms the heart of your microcontroller. I can say it's not heart, it's a brain of your microcontroller. So for a human body, what a brain will do actually, though it occupies very less space in your body, it controls every part of your body, right? The CPU is the same for your microcontroller. So it will not occupy the entire microcontroller, but it is a small part here. But you can see that the CPU connects to everything, whether it is interrupt controller, oscillator, or bus controller, on-chip RAM, by ports, to everything, to every other functional block it is connected. So it performs what the brain performs in your body. What brain performs in your body, it process everything. Okay, takes input and it gives process and it gives output. Okay, the brain actually what it will do, it will not directly take the input through your hands or through your senses. It will take the input, it will process, and it will give you output. The output is again handed over to your senses. The same thing will happen in your microcontroller with respect to your CPU. So what CPU will contain? It will contain arithmetic unit, arithmetic logic unit, and control unit, and other important components like register, array, etc. Okay. So what is the prime purpose of your CPU? So CPU, it connects to every other functional blocks, every other circuit, and it's a primary device in communicating with all the devices, all other functional blocks like your memory input and output. So what CPU will do? It reads instructions or the set of instructions called program. So it reads the instructions or program from the ROM where it was stored, and also data from the RAM, and process the data accordingly and gives the result as output. Okay. So if we go in detail, since the CPU contains ALU or arithmetic logic unit, what it arithmetic logic unit will do? It performs the arithmetic and logical operations. Arithmetic operations means all your plus, minus, divide, multiplication, etc. And the logical operations means logical and or nor, not, etc. Okay. So this ALU, which is a part of your CPU, is responsible for performing all these arithmetic and logical operations. So what is ALU? It is a circuit. Okay, it's a circuit inside your CPU. Similarly, you have one more circuit inside your CPU that is called as control unit, and this control unit is responsible for providing certain timings for the communication process between your CPU and other functional blocks. So here you can see that the CPU is actually communicating with all other functional blocks, and you can see that if every functional block, if every other circuit want to communicate with CPU at one particular instant, it cannot. Okay, so there must be, the CPU must will provide certain timing for every other functional block, so that the things will happen sequentially one after the other. That means if it want to communicate with, if ROM and RAM want to communicate at the same time with CPU, it is not possible. The CPU will provide the timing for ROM so that it communicate at one instant. It will also provide the timing for RAM so that it will communicate maybe later. Okay. So to sequence, so number of operations will occur inside your CPU, inside your microcontroller, and to sequence and to control every other functional block, certain signals are issued by your CPU by using of control unit, and these signals will tell the other functional blocks when to communicate with CPU in what way. Okay, so next we have memory. Memory part, you can see that the memory part is shown as in two different functional blocks. One is on chip RAM, other is on chip ROM. Okay, so what is the purpose of this memory? So on chip RAM, on chip ROM, first we'll see on chip ROM. So on chip ROM, it is also called as program memory or code memory. So how much is this for your 8051? So for 8051 we have 4 kilobytes of ROM or program memory or code memory. So what is the purpose of this program memory or code memory or ROM, on chip ROM present in your 8051 is all the instructions of the CPU that we have given. Okay, so in order to perform a task, we have to issue number of instructions to your CPU, and that will type through your keyboard. Okay, and whatever the instruction that we type through the keyboard will not be directly executed by CPU, but will be stored in the so-called program memory or on-chip ROM. So the instructions of the CPU are stored in the program memory, and it is usually implemented as read-only memory. Why? Because the read-only memory is non-volatile. That means when power goes off, the contents of the ROM will not get erased. So whatever the instruction that we have written, to be retained even though power is off. Okay, so that's why the instructions are stored inside your program memory or code memory or on chip ROM. All the names are synonymous. That means you can use all the names are equal: program memory, code memory, or on chip ROM. And next we have data memory. So data memory is in a microcontroller. For example, you are performing number of operations and you will get the results immediately. The controller will perform the number of operations. It will get the results after performing the operation. So the result is directly not given to the output device, but it is stored somewhere temporarily. And where it is storing that memory, we are calling it as data memory. Okay, so data memory in a microcontroller is responsible for storing the values of variables, temporary data, and intermediate results, and other data for proper operation of the program. So either the data అనేది, if you want to store it temporarily, then the data memory or on chip RAM will be used to store the temporary data. Okay, so data memory is often called as RAM, and you know that it is a type of volatile memory. That means the contents are erased when power goes off. And this RAM, how much is the size of the RAM for 8051? In features we have seen that it is 128 bytes of RAM is present for your 8051, and this 128 bytes of RAM is actually organized as 128 memory locations. 128 memory locations, each memory location is of 1 byte width. That means it can accommodate, each memory location can accommodate 1 bit of 8 bits of data or 1 byte of data. And some of the memory locations are treated as registers. Okay, so I can say that the on-chip RAM that is present, 128 bytes of on-chip RAM, is actually organized as registers and few registers, and remaining are memory locations. So next we have bus. Okay, so bus control or bus. So here you can see that the one more. So what we have completed so far, it is CPU, and what is the purpose of CPU, what is the function of CPU, what is the function of this on-chip ROM, and what is the function of this on-chip RAM. So these are the three functions that we have completed. So we have one more functional blocks that is called as bus control. So bus control, before going to bus control, we have to see what is the bus. What is the bus? So you can see that all these functional blocks, different functional blocks, are actually connected by certain arrows, a single arrows here and double arrows here, and in these arrows actually you can see that what is these arrows actually, they are the connecting paths or the conducting paths between one circuit to other circuit, or one functional block to other functional block. And this connecting path from one circuit to the other circuit, or from one functional block to other functional block, that is present on the IC is called as bus. So actually bus means a group of such connecting wires. Okay, not a single wire, but a group of connecting wires is called as bus. Okay, and there is a bus which is connecting all the functional blocks to CPU and CPU to other functional blocks. So, but your 8051 has the total bus is actually, or you can see that the bus, how bus is defined as a collection of wires which work as a collection of wires, means through which data, the ones and zeros will actually travel from one circuit to the other circuit. So it's a collection of wires which work as a communication channel or a medium for transfer of data from one circuit to other circuit on your 8051 IC. Okay, so that is called as a bus. And you have three different types of buses that exist in your microcontroller 8051. So the first one is called address bus, and second type of bus is called as data bus, and third type of bus is called as control bus. So what is address bus? So the microcontroller 8051 microcontroller has the 16-bit address bus. See, bus means it's a collection of wires. So here this address bus is actually used to carry the address. Is actually used to carry the address. Address bus means it's a collection of certain number of wires. And for 8051, that number is actually 16. That means 16 number of wires which carry the address, that we are calling it as address bus. So what is this address actually? What is this address? It's the address of certain memory location, okay, or it's address of certain uh, input output device. See, the controller actually can be connected to a number of input output devices, or it can be connected to number of memory locations. To identify one out of all the memory locations or one out of all the IO devices, every memory location or every IO device is provided with certain address. So that by seeing the address, it can say that so it is accessing this particular memory location, or it is connected to this particular input output devices. For example, if in a village there are number of persons are there, how to identify the person? The person may be residing in his home. Okay, so we can identify the home by the address of the home. Okay, then we can connect to that person. In a similar way, CPU actually when it want to connect to a memory location or an input output device, it will do that by allocating different addresses for all these memory locations are all these input output devices. Okay, and in order to identify the particular memory location or particular IO device, its address is to be placed. Its address is to be placed on this address bus. Address bus means 16 number of lines. That means on each line you can place one bit. So on 16 lines you can place 16-bit address. Okay, so that is why the 8051 has 16-bit address bus, and it is used by the CPU to identify a particular memory location out of all, or a particular input output devices, by placing the address of that particular memory location on this address bus. Okay, right. So next we have data bus. So this is very different from the address bus. It is also a bus. That means it is also a group of files. Okay, but here 8051, for 8051, this group consists 8 wires. So whatever the data that 8051 requires from any memory location or any input output device, it will receive that data. It will receive that data, or it will send the data on this data bus. Okay, and this data bus, that means we have 8 wires. It consists 8 wires, means on each wire you can place one bit of data. So total 8 bits of data can be transferred at any time from CPU to memory location, or from CPU to IO device, or from IO device to CPU, or from memory location to CPU. Right. So next we have one more bus is called, that is control bus. So this control bus is actually used by your CPU to control or to issue various signals to your the input and output devices or the memories. That for example, if it want to write something into memory, or if it want to send some data to your input output device, before sending the data it will issue one signal that I am sending this data to you. That type of signals uh, are issued on the wires, which are called as, which constitute your control bus. So what is this bus totally? Actually, it is a bunch of wires to communicate between these functional blocks. Address bus is used by the CPU only to identify other devices by placing the address, and the address is 16-bit always. And data bus is used by either CPU or memory or IO devices to transfer data from one functional block to other functional block, and the width of data bus is 8 bit. The control bus is again used by the CPU only to issue various signals to your IO devices or memory. And also you have some special type of control circuitry is there, and that is called as timers and counters. Did we and it has some more circuitry that is called as timers and counters. So 8051 has two 16-bit as such, two 16-bit timers and counters. So they are named as timer 0 and timer 1. So these are actually they are the registers. Okay, so these can be used as timers or event counters. So timers means they actually indicate, they provide certain timing for each and every task, and counters means they will count the events. They will count the events means, for example, one person is entering into the room. Okay, how many persons enter the room is, entering one person is one event, entering the second person is second event, and so on. Okay, so the activity, okay, so one particular activity is called as one event. So to count the number of activities that happen, we'll be using these counters which count those events. And similarly times are used to maintain the time delays. For example, when you are performing the task, between different operations you require some time delay. Okay, and in order to provide the time delay between the two different actions or two different operations, we will be using the circuits called timers. Okay, so here that type of circuits are there for your 8051, and they are called 16-bit timers with the names timer 0 and timer 1. Next important circuit is your clock generator. So what is clock generator? Why it is required means, so since your 8051 digital IC is a sequential circuit, right? So it requires a clock signal, and clock signal for to make all the operations are synchronous. That means to synchronize all the operations, it requires one particular signal that is called as a clock signal, and this signal is generated by the clock generator circuit or oscillator circuit. Next you have input output ports. So what is this input and output port? If we can see that, if you can see this IC, okay, you can see that there are number of pins which are available. Okay, so which are actually connecting points to the circuit that is present inside your IC, right? So what is this input output port means? Actually, uh, all these lines that are actually provided for physical connection, provided for the microcontroller for physical connection to outside the chip. Okay, so if you want to connect anything to your microcontroller, you can use all those IO pins, input and output pins. Okay, so we have 32 of such IO pins through which um, you can connect to the circuit, can connect to the microcontroller inside the IC, right? So all those input and output, 32 input and output pins are actually grouped into four ports, each port containing 8 IO pins, 8 IO pins. And what the purpose of this input and output ports? So each of the 32 IO pins, why we are calling it as IO pin? Either we can call it as input pin or output pin. So that means the same pin can act as input pin at some point of time. Later we can use the same pin as output pin. So similarly, all the pins, since they are grouped into IO ports, we will talk in terms of IO ports. So the ports can be either used as input ports or output ports. And when you are using it as input port, what it will do? It will provide a gateway for passing on the data from outside world with the help of sensors. So when you are using it as input port means through those ports the controller will get the data from outside world. Okay, from outside world నుంచి data ఎట్లా వస్తుందంటే with the help of sensors. For example, there is a sensor which detects whether there is a light or not. When there is a light, it provides input 1 for your microcontroller. When there is no light, it provides an input 0 to your microcontroller. In that way, input ports provide a gateway for passing on the data from outside world with the help of sensors. So the data from input port is actually manipulated. That means it will be processed. That means whatever the data that you are getting from the sensor which is connected to the IO pin is processed, and it will determine the data on the output port. So what is this output port? So by using output port, whatever the microcontroller want to give the data out, it will give the data out on your output port. So that means it will process the data, and when you want to give the data to the output world to control other devices, for example glowing an LED or switch off, making the LED off. Okay, so in order to glow the LED, the controller has to give out a bit 1, and that it can give from output ports. Similarly, in order to switch off the LED which is connected to output pin, the controller has to give bit 0. So generally all ports of microcontroller have dual functionality. That means they can act as both input port and output port. Similarly, you have other important circuitry that is present on your 8051, that is called a serial port. So normally you can see that the computers can transfer the data in two ways. One is parallel, other is your serial. You know what is meant by parallel and serial communication? Parallel means all the bits are transferred parallelly at once. And serially means the bits are transferred one by one. Okay. So through serial port, the serial communication is possible with your microcontroller. The bits are sent one by one, either from outside world to controller or controller to outside world. So the 8051 has one such serial port for this purpose, and it is of full duplex nature. That means simultaneously it can receive and transmit the bits serially. And we have one more important circuit that is called as interrupt control. So what is an interrupt? So when microprocessor is doing some operations, if some device, some input output device has an important work that is to be done by the controller, then the input output device asks um, for the time of your controller, and that asking is, so the interrupt signal is actually sent by the external device to the microcontroller so as to request the controller to perform a particular task for it. Okay, so that means, for example, a printer is there. A printer, when it is connected to controller, when it want to print, requests the controller for its services by sending the signal, and that signal we are calling it as interrupt. Okay, in order to perform it's a task of printing, right? So when an interrupt is received by the controller, it will see whether it is important or not. And if it is important, it will stop its work and it will attend the function of the input and output device. So the interrupt control unit that is there, okay, that is present for your microcontroller. So this is the interrupt control circuit, and for this circuit actually it receives the interrupt request from the external IO devices, or it receives the external interrupts, and this interrupt control will process the interrupts first, and then it will hand over the request to your CPU. So the interrupt control unit transfers the microcontroller attention from one task to other, or it takes the microcontroller time from one task to other. Generally, we have five interrupt sources provided for your 8051 microcontroller, and the names of these five interrupt sources are five interrupts. We call them as interrupt 0, interrupt 1, and timer flag 0, timer flag 1. Next, receive and transmit interrupts. So this is the complete description of the functional block diagram of 8051. So uh, let's see what we have covered. We have covered the features of 8051, various features that are available with 8051 microcontroller, which can be used to write programs to perform a specific task. And in detail, we have seen what are the various functional blocks into which the 8051 circuit can be divided into, and where we have seen that it's a CPU and oscillator circuit and on-chip ROM, on-chip RAM, and also have IO ports, serial ports, and timer circuits, timer 0, timer 1. We have a bus control and also interrupt control. And we have seen in detail the functions of various blocks. And this concludes the lecture. Thank you.